Okay, so hi, I'm going to walk through this process of solving a SQL question, and the problem we're tackling involves finding top 3 high earners in each department within a company's database. To do this, we'll be using SQL queries to retrieve the necessary information from 2 different tables. The tables here shown in the original problem, we have table 1, employee, and the other table is department. And it's important to note the primary key and the foreign keys, which we'll use later when it comes to joining. Okay, and so let's see. Right. And so I'm going to share my solution to the problem, and I'll go through it and just kind of we'll walk through it step by step, explaining what I was thinking. So first is the crucial select clause, crucial to any SQL query. So here we're selecting the columns we want to include in our result set. And it's worth noting that we can select columns from both the employee and department tables in a single query because we join the 2 tables together later on. And then also to avoid ambiguity, it's crucial to use aliases for column names when dealing with multiple tables. Here we've chosen department as an alias to represent the department name. That's right here. And then you see that going down, employee name as employee from the employee table, and this is salary from the employee table as well. These are the 3 aliases that we're used at this point. And additionally, from employee as E. So we're kind of using E as an alias also. And we explicitly specify which table each column comes from, making the query unambiguous. And if we fail to do this, it'll likely throw an error. So it's important working with multiple tables to ensure the database engine knows where to fetch data from. It clarifies the source of each column, making the query more straightforward to read also. Okay, so in the from clause here, like I mentioned, we specify the tables we're using, and we begin by aliasing the employee table as E, and to simplify references in the query. And then afterward, in the join clause, we introduce the department table with the alias D. So that's here. And let's see. And then here we're going to get into we call it subquery. And we're going to do this for ranking purposes. This is, the crux of the issue of the problem here. So in this context, the where clause selects rows from the employee table that meet specified conditions. So we use conditions to filter and rank employees within their respective departments. Let's see here. And the subquery begins with the select statement. Gotta have that crucial select clause. And within the parentheses, we have our count distinct salary. And this part of the subquery calculates the count of distinct salary values. And by using distinct, we ensure that each unique salary value is counted only once within a department. It's essential to avoid counting the same salary multiple times. And then let's see. So from employee, we specify the table we're using for the subquery, which is the employee table. And the where, this line right here, is a filtering condition for the subquery. We are comparing each employee's department ID with the department ID of the current employee. And then, that's denoted with the E.department ID. And then additionally, we compare the salary of each employee with the salary of the current employee. You may be asking yourself, what is the current employee? Well, I will break that down a little bit more. So current employee represents is in this subquery is current employee is used as a placeholder to represent the employee being examined at a particular point in the query. It's important to note that the current employee changes as the query processes different rows from the employee table. So in this context, the query checks 2 conditions. It compares the department ID of the current employee with the department ID of other employees to ensure they belong to the same department. And then another crucial comparison, or one of the conditions, it compares the salary of the current employee with the salaries of the other employees in the same department to determine if the current employee has a salary greater than or equal to their peers. So current employee, just to kind of finish up with that is that it's a dynamic and it refers to the employee currently being processed by the query as it makes its way through, row by row. And then, so it's a dynamic evaluation. It's a key part of the process for finding the top earners in each department. Okay. So, and then also, when we use the count in the main query's where clause to filter the employees, we restrict the result to only include employees whose rank determined by the subquery is less than or equal to 3. In other words, we select the top 3 high earners within each department based on the ranking calculated by the subquery. So, let's see. Yeah, let's see. So the result of the subquery is a count of how many employees within the same department earn salaries greater than or equal to the current employee's salary. That's what it's doing internally. This count essentially ranks the current employee within their department, which is what we need. So that's great. Let's see. And then we compare the count of distinct salaries with a limit of 3, because we're only concerned with the top 3 earners in each department. That's how we, the problem defined a high earner as the top within the top 3 highest earners in each department. So this ensures that we only receive the most elevated, the highest, second highest, and third highest earners in each department. Okay, and then finally, so that was all this. And then now we move on to order by, and this is just, for presentation purposes, so to speak. So firstly, we order by d.name, which this is, department name is a variable character or a string. And so this essentially, and I don't designate anything, so it just defaults to ascending. So essentially, it's just going to order them by name, department name in alphabetical order. And then salary descending is going to start with the highest paid and work its way down. And that'll also, be by each department. Okay, and so that's it. And so I will run this now, and then we'll get the results. And each department should be sorted by department name and employee salary. And accepted. And here is our output. And we see, and just a little side note too, Joe and Randy both have the same salary. So they're both within the top 3. That's why there are 4 people there. So, okay.